slope formula. The other was getting a negative slope. Here's the third scenario where you just end up getting zero slope because you end up getting a 0 on the numerator. And when this happens is when you move from left to right, your y values are not going to be increasing or decreasing. They're just going to be staying the same. So here are two ordered pairs, and I'm going to compute the slope algebraically and then see how that ties in with the graph. So let's go ahead and apply the slope definition to this. The slope formula. M is equal to y2 minus y1, and again I'm just going to stay consistent and call this x1, y1, x2, and y2. So the slope of this thing would be y2 minus y1, which would be 5 minus 5, and x2 minus x1, which would be 2 minus 1. So 5 minus 5 is 0, and that's what I was trying to get at when I was saying you'll end up getting 0 on the numerator or the top of the fraction. And 2 minus 1 would be 1, and 0 divided by 1 is 0. So you end up getting a slope of 0. And let's see how that looks graphically. So we said our slope was 0, right? And let me just plot my points like I always do. So 1, 5, 1, moving over horizontally once and up 5, so 1, 2, 3, 4, 5. That's the point 1, 5 right there. And 2, 5, over 2, up 5, 1, 2, 3, 4, 5. They're right next to each other. So if I were to connect these 2 points together, they would form my line. So again, this point right here was 1, 5, and that point right there was 2, 5. And we said when you get the third scenario, I would like to call it a special case. I don't know if everybody would call it that. You end up getting a slope of 0. So as you move from left to right, your y values don't increase or decrease. They just stay the same. So here, let's use a different color. I see that my y value was 5. And then as I move from left to right, my y value stayed as 5. So it didn't increase or decrease, it just stayed the same. So when you end up getting a 0 on the numerator, as we showed the computation, you end up, the whole slope turns out to be 0, and then you end up getting a horizontal line, meaning that your y values will always stay constant. So this is the third case. Okay, so for the third case, we ended up getting a slope of 0, which gave us a horizontal line. So why don't you guys give this a try and pause the video and whatnot, and I'll go over it with you guys. I just wanted to point out, if your y values are the same number, the third case is going to happen. Let's see how that plays out. Again, I'm just going to call this x1, y1, x2, and y2. You're more than welcome to go at a, doesn't really matter how you label these like we said earlier. So the slope formula says that you take y2 and you subtract that from y1. So negative 4 minus a negative 4. Again, be careful on those subtractions there. Then you take x2 and you subtract it from x1. So 5 minus a negative 1. Okay, so just move over here. Again, 2 negatives turn into a positive, right? And if you have 4 and you take away 4, you'll end up at 0. And 2 negatives again make a positive, so 5 plus 1 is 6. But really, if you have 0 on the numerator and a number on the bottom, that'll just turn into 0. So again, we get that our slope is equal to 0. So now let's see how that looks graphically. Okay, so we got that the slope was equal to 0. I'm going to first plot my points. Negative 4, negative 1, negative 4. So here's negative 1. We're going to go down 4. 1, 2, 3, 4. Right there. 5, negative 4. So 1, 2, 3, 4, 5. We go down to negative 4. 1, 2, 3, 4. And if I were to connect these lines, we got all the colors in the world to deal with, so why would I just keep using the same ones, right? So this point right here was negative 1, comma, negative 4. And and this new point was 5 comma negative 4. So as we said for the third case, as you move from left to right, your y values are not going to increase or decrease, they're just going to stay the same. So here I can see that my y value is negative 4, and at this point my y value is also negative 4. So they just stay constant. Yeah, so for this third case, you'll always get a horizontal line. Depending on your y value, that's where it's always going to stay constant. So here, it's going to keep staying constant at negative 4, regardless of what x value it is. It's always going to land on negative 4, creating that horizontal line. Okay, so we're down to our last case, the fourth case. We looked at positive slope, negative slope, zero slope. This fourth case, I would also call this a special case. You end up getting undefined slope because you have way too much rise and no horizontal change. So you just have no slope, because what happens is for the third case, remember, you end up getting 0 on the numerator, so your slope ends up being 0. This time you get a 0 on the denominator, which is undefined. You can't divide by 0. If you try that on the calculator, it will tell you undefined, and we know algebraically that we can't divide by 0 also. Here I have two ordered pairs, and I'm going to go ahead and use the slope formula to do it algebraically to see what happens. So let's call this guy x1, y1, x2, and y2. So the slope formula tells me to take y2 and subtract it from y1. So negative 2 minus 5. And then it says take x2 and subtract it from x1. So 1.5 minus 1.5. Negative 2 minus 5 would be negative 7. 1.5 minus 1.5 minus 1.5 would be 0. Okay, so since we did the algebraic manipulations with the slope formula, we got negative 7 over 0, and we concluded that that was undefined. If my explanation wasn't good, my friend Chris made a video about how dividing by 0 is undefined, so you can check that out if you wanted more explanation. So let's go ahead and plot these and see how it would look graphically. So 1.5 up 5, 1, 2, 3, 4, 5 would be right there. 1.5 negative 2, 1, 2, 3, I'm sorry, negative 2, 1, 2 would be right here. Connecting these, I see that I get a vertical line. So in conclusion, if you get a horizontal line, you could tell that the slope is 0, but when you end up getting a vertical line, that's when you have way too much rise and no horizontal change, which makes the slope undefined. So whenever you end up getting a vertical line, you could conclude that the slope is undefined. Okay, here's our last example here. 3 comma 100 and 3 comma 25. We know what the slope formula is, y2 minus y1 over x2 minus x1. And I just always label my first ordered pair as x1 y1 and x2 y2. So I'm going to take the difference in y's and divide them by the difference in x. Notice here that your x values are the same. So when we compute that difference, we're going to end up getting a 0 on the denominator, and we know that that's going to give us an undefined slope because you can't divide by 0. Just something to keep in mind, but we'll also see that with the computation. So y2 minus y1, that'll be 25 minus 100 over 3 minus 3. So we're going to get m is equal to negative 75 over 0. This is what I was talking about when I said you'd get a 0 in the denominator because you can't divide by 0. So in this case, our slope ends up being undefined. And we know that when our slope is undefined, we get a vertical line, which is just way too much rise and no horizontal change. Okay, so we talked about the 4 different cases. The case where you get the slope to be a positive number when you compute it in the slope formula, and that lets us know that your y values are going to be increasing when you move from left to right. The second case was when you, after computing the slope, you get a negative number, which lets you know that moving from left to right, your y values will be decreasing. Third case was where you end up getting a 0 on the numerator, which ends up making the whole thing 0 if you get a number on the bottom. And that let us know that we got a horizontal line, which meant that our y values were just going to stay the same as we move from left to right. They weren't going to increase or decrease. And the last case we looked at is when we got a 0 on the denominator, which made the computational not possible because we can't divide by 0, which gave us an undefined slope. So thank you guys for watching these videos, being patient with us. Hope to see you next time.